Good evening, one and all present here. We welcome all the participants and guests for the ninth session of today ATAL Faculty Development Program on effects on global warming and management. Today's guest, Dr. G.S. Ram Pradeep sir, professor at Kongi Engineering College, Erode. Previously, he handled the first session. Today, he is going to take the above topics. We welcome you for the session, sir.
6:30 January. Yes, ma'am. Am I audible, ma'am?
Yes, sir. Audible, sir.
Okay. Just a minute, ma'am.
Okay.
So, a warm good evening to one and all gathered here. I think the session on disaster management is going very well. Today is my second session. Day before yesterday, I have shared the artificial intelligence tools which we can use for the disaster management. So now I am going to discuss more about the global warming, what are its causes, what are its effects, and how we can manage the same. So today's in discuss point of view, global warming is the major scenario where not only in India, major parts of the world. So alternatively, what I can tell, every parts of the world in the technology, we are focusing much how we can reduce the effect of global warming in the scenario, right? So more technologies and more researchers, they are doing on how to reduce the emission of contaminated gases and how to control the emission, right? Say for example, take a cement factory, right? So huge amount of flue gases it is emitting because of the incineration, high temperature beyond 1000 degrees centigrade, right? So it is the need of the day. At the same time, we are facing the huge crisis and the huge drawbacks on the effect of global warming. We need cement, right? I'm pointing one example. Then I will point the subsidiary examples because some of the other branches, faculties, and other researchers also joined in this course. Uh, Take for the scenarios cement factory. We are producing the cement with respect to the limestone, right? Uh, After many process, it is coming as a cement bag per 50 kg. Bag is contained of 50 kg. But the prime raw material is the limestone, and after many process, we are getting the powderious material, right? During the intermediate process, a huge amount of CO2 is getting liberating, right? So in turn, it creates the global warming, and the world is expecting how to control this. We need to meet the demand for the demand supply chain, right? We need cement for generating the infrastructure, but at the same time, the world is facing the global warming issues. Is how we can manage this. That we will see in the detail. Is the slide is changing? Please confirm, ma'am. Is the slide is changing?
Yes, sir. Yes, sir, it
Okay,
is
thank you.
changing.
Yeah, thank you. So, in primary, the outset, global warming is the sustainable or long term or the durable, right? Global warming is not durable, but it is a long term process or long chain process which will increase the Earth's average surface temperature. This is obviously true because the ground part of the Earth is consists of crust, mantle, and core, as we know that very well, right? In the core part, it will be classified into two, inner core and outer core, right? So where the liquid stage of phenomena will be there, right? So during the eruption of magma, so the rock will be formed. That rock will be classified into two, intrusion and extrusion process, right? So the top layer is called crust, which will be the hard layer, and the mantle, which is the intermediate layer, where it is a semi-solid, right? So in average, if we see that day by day, the Earth's scenario or the core temperature is getting increased, right? So it is because of global warming effect, because of improving in the technology, we are reducing the natural phenomena. Take for example, deforestation of the trees, right? So if we are cutting the trees, we are extending the road, we are making the extension of the road, right? Uh, we are facing so much amount of the increase in temperature of Earth, which will term as the global warming, right? So it is mainly because of the expecting the meeting of the humans. That is the human because of the human activities, right? I will point one example. In earlier days, there is no much amount of the vehicles, right? Huge amount of trees were there. There is no much amount of vehicles. Only the bicycles and very, very rare cases, the automobiles were run, right? And after that, there is a migration of the technology and the usage of automobiles was increased from the cycling to the motorcycle. Then, in order to meet the demand, we are tends to increase the production of motorcycles and finally went to the car, four-wheelers, etc. Right? It is a cyclic process, as I told earlier. So everywhere, if you are seeing, so much amount of four-wheelers are there, right? So if you are traveling from one place to other place, the expulsion of the CO2 is much increasing from the silencer. For that, the Tesla car came, which is the automation or the battery-based vehicle, right? So in the bottom photo, I have commented two things: natural greenhouse effect without the human activities, and right side photo indicates human enhanced greenhouse, that is the man-made. Not only the man-made, see, the disasters is happening because of the man-made. Natural disasters also there, but the natural disasters triggering is because of the man-made effects, right? So, in human enhanced greenhouse effect, there is a solar power is there, that is a sun. The radiation is coming, which is called the solar radiation. It is coming inside the earth, right? At the same time, the red zone outside, which is plotted, is the more emission of the radiation or heat is getting generating or it is getting emitting, right? What is the source of heat emitting? Vehicles, factories, right? Huge amount of chimneys, bunkers, right? It is more amount of heat is emitting, right? Yeah, or it gets emitting into the or escaping into the space. And some of the radiation is back into the earth surface, like other than CO2, ammonia and nitrogen oxide, many things is plays a vital role in the human and gas greenhouse effect. So this process is continuously reacting and the action of the force is called the global warming, right? So what are the effects of global warming which will create the environmental crisis or by raising the sea levels? So as you pointed here, increase in the ocean's average height caused by many issues like melting ice caps, glaciers, thermal expansion. So these thermal expansion not only happening in the global warming effect, also you take the bridges, there will be a thermal expansion. You take the yes, some portion of the concrete. Take for example roof slab. There will be a thermal expansion. So these thermal expansion is creating because of the global warming. And if you take the concreting part, the steel part will not get affected. So if the steel part is not get affected, somewhat the disaster can be get arrested, right? Suddenly the concreting part is getting affected. right? Because of the thermal expansion. What are the key causes? What are the main causes for this scenario is, as I already pointed, glaciers and melting of the ice caps, thermal expansion of seawater, as well as ice sheet losses in the some places of the world. So these are the key causes, and what are the major impacts? Causes flooding, as I have already pointed in the last AA tool, right? More disasters is by flooding and the uh, earthquake, right? So what are the types of flooding and what are the other major impacts that will create because of increasing in sea level due to global warming? So coastal flooding, erosion and habitat loss, right? Take for example Wayanad cases, more amount of erosions, right? And take an example of the seashore area, right? More amount of eroding of material is happening. The fine particles are getting eroding. In some cases, there is a possibility of corrosion also, right? Small quantity of particles will get eroded and it will get affect the steel which is inbuilt. So that as per the Indian standard practice, when the buildings are constructed in the seashore area, because of the erosion and because of the chloride attack, right, we are increasing the cover depth of the steel, right? Normally, if you are giving 40 mm, so if we are constructing the building in the seashore, we will increase the cover depth to greater than 50 mm, right, in order to protect the steel from the corrosion, which will cause a slow by day because of the erosion process, right? And saltwater intrusion. Intrusion is means from one point to other point. Take for example, if we are telling the permeability, the intrusion process of water is from top to bottom in a vertical way. If we are telling the sorptivity, it is the capillary reaction from the bottom to top. It is like an intrusion, how it flows due to the gravity from one point to other point, right? So saltwater intrusion is a very a negative phenomena exclusively for the RCC, right? So in IS 456, it is clearly mentioning, right? So you need to correlate both the things. Why the global warming is happening? What are the causes? If the global warming is happening, how it affects these structures, right? So in IS 456, it is clearly mentioned between the PCC and the RCC. For example, if I am using the PCC, if there is an action of salt to water, right, there will not be any problem other than the surface phenomena, whether it will be bulged or there will be a some disturbances will happen inside the concrete. For PCC, I'm telling, if it is greater than 2200 kg per meter cube. Take for example RCC. It's very dangerous phenomena. Exclusively, I already pointed the buildings which is constructed in the near to the seashores. The salt water, it is a Cl minus sodium chloride, Na plus and Cl minus. The chloride ions will migrate from one point to other point, right? So it will affect the passivating layer of the film. That is the steel. There will be a nano coating of the steel. If the salt layer, if it's getting deposited. Hello? Hello? Am I audible?
Yes,
Am I
sir.
audible, sir?
Yes,
Okay.
audible, sir.
Okay, fine. Okay, fine. Thank you. So, salt water, if it is getting intrusion, there will be a nano coating will be available over the steel. I'm not pointing the epoxy coating. I am generally telling the normal TMT. So, what the salt water will do, it will affect the nano coating and side by side, it will destroy the passivating film of the steel. Passivating layer is nothing but it's a nano layer which will protect the steel from the external disturbances, right? It's like a skin which is protecting the bone, right? So nano layer or passivating layer is like a skin. Bone is like a steel, right? So if the acid is poured over the skin, it will destroy, right? So suddenly it will enter into the bone. So likewise, uh, the skin is like a passivating layer and steel is like a bone. So ultimate aim is to protect the skin in order to protect the bone or to protect the steel. So how we are controlling the salt layer intrusion, right? So if we are controlling the global warming, if we are controlling the flooding, or we can control the erosion. So side by side, we can also control the saltwater intrusions, right? So there will be also the economic losses because we are uh, preparing the scheduling initially using the Primavera or many other softwares, right? So MS Office or Primavera, MS Project or Primavera, we are using to plan and scheduling to maintaining the activity. And we are also giving the budget abstract estimate for detailed estimate for doing the activity, how much amount we need to spend for constructing the building or producing one element. So if we are not controlling the basic global warming, ultimately the economic losses will be there, which we spent already, right? And finally, the displacement, right? So these are the major impacts which is creating due to the effect of global warming, mainly due to the a slight increasing in the level of sea. So here, what you can see is the effect of global warming comes under the environment only because of the extreme weather events, right? So the weather events is classified or which will increase the frequency, intensity, and duration. So this is not applicable only for the flooding. This case is applicable for entire scenario. Take for example, I will correlate this. You can take the flooding, you can take the fire, you can take the earthquake, you can take the wind load, all the things, right? These 3 points will comes under the main criteria like frequency, intensity, and duration, right? So I have pointed here what is meant by the global warming. What are the things we can point like storms, drought, and heat waves? You can classify this for your research, right? So I have marked in the right side latitude and longitude for the different scales where red is the top and blue is the bottom range, right? So here in the last presentation, AI tool, I have pointed as per IS 1893, I have told zone 2 to 5, it was classified into in IS 1893. But in earlier cases, it was mentioned from zone 1, 2, 3, 4, 5. Right? But here, please be very clear that uh, if you are using the IS 875 part 4, this is called earthquake. IS 875 part 3, right? This is for wind load. If the assume that I have constructed a tower, cell phone tower, which is of 70 meter or 50-meter height, right? You know that when the height is getting increased, right, the wind velocity will be more, right? In order to arrest the shear, there will be a high amount of moment will be there. So the base width of the steel tower will be higher at the bottom. So you just correlate this. What is meant by weather and why I am talking like this, right? The frequency of wind waves as per IS 875 will be classified depend upon there be a uh, different ranges, right? If the tower is located or the building is located in Coimbatore, like 50 kilonewton per meter square. If it is located in Pollachi, if it is located in Chennai, if it is located in Delhi, the wind velocity will be different. Based on that wind velocity only, we are designing the appropriate elements, right? So, in addition to that, you can take IS 456 also. Why these weather conditions plays the major role? Is anybody trying to guess why these weather conditions plays the major role? Because in IS 456, you can take table number 5, right? They have classified very clearly for the importance of weather. So they have classified into 5 types: mild, medium, right? Uh, Severe, very severe, extreme. Like that, they have classified mild, medium, severe, very severe, extreme. So based on that weather condition only, we are taking particular project and we are fixing in which weather condition we are designing. I will give you example. If you take the Kashmir and if
It is a small instruction to the participants. 80% of attendance is mandatory. Check the individual portal login. Any difference any doubts can contact our team. 70% test mark is compulsory. Prepares for tomorrow's test. Test and common feedback session starts from 6:30 to 7:30 p.m. on tomorrow. Common feedback form is available in individual ATAL portal. Carefully submit the feedback form. If any doubts, contact our team. Feedback and test marks are necessary to get certificate. Best of luck, dear participants. Participants, kindly wait for a few minutes. If you are facing any issues during your attendance related marks, you can contact us. Kindly check your individual portal for your attendance.
Sir, am I audible, sir?
Sir, now it is audible, sir.
Yes, sir.
Okay, sir. Okay.
Screen, sir.
Okay. Thank you. Thank you. There's a screen, sir. So is my screen visible, sir?
No, sir.
It's not visible, sir?
Yes, sir. Not visible, sir.
Okay, just a minute.
Sir. Now it is visible, sir.
Is my screen visible, sir?
Yes, sir. Now it is visible, sir.
What is that heading you are seeing, sir? Which is the slide?
Sir, heading key impacts.
Key impacts,
Economic
economical
effects,
effects,
infrastructure
infrastructure damage. Okay.
Yes, sir.
Okay, sir. So this is the economical damage which is creating for the infrastructure, right? Because of the vibration or earthquake which is happening to the bridges or flooding which is happening. As I already pointed, there is a thermal expansion or thermal behavior or thermal interaction between the environment and the surface what we are studying or surface where we are living, right? So I will tell you one example. There is a fresh concrete we have laid, right? So it is opening to the atmosphere. In some cases, there is a possibility of self-desiccation. Self-desiccation means evaporation, evaporation of water in its own from the top surface, right? So due to the why the evaporation is happening, if the top layer is subjected to more temperature, the water layer, if it is presenting in the or moisture, if it is presenting in the surface of the concrete, so it's get evaporated because of the over temperature. And if the water is getting evaporated, that water will not enough for the hydration, right? That water which is evaporated is not sufficient for doing the hydration. So there will be a formation of shrinkage and there is a drawback of crack and there is a drawback in the element, structural element because of the cracking and debonding or disruptions, right? So this is mainly because of the infrastructure damage exclusively creating due to the global warming. So mainly because of the social effects, because of displacement and inequity, right? So millions and millions of people facing these critical issues, right? And they are migrating. If the flood is happening, they are migrating from one place to other place where they are very difficult to live. The main difficulty of not living is because of it's very pathetic to uh, to drain the water, right? So drainage of water is very, very important. For that cases, the special concretes we are using the no fines concrete, and the government is also promoting much more to go for no fines concrete or pervious concrete where we are completely avoiding the usage of sand. So somewhat if we are using like this, we can somewhat drain the water away, and in some places it's very difficult to pump the water away, right? So huge amount of water is getting stagnating. So finally the life of the people for the business and the daily wages people facing so much of crisis in this. So finally, they are moving from one place to other place, right? The Arctic ice melting is of warming nearly twice as fast as the global average. So there will be a global average scenario for every places. So in the Arctic place, the warming will happen twice the global average, which will lead to the major ice losses, right? So what are the key impact of creating this? Because of increasing in sea level, ecosystem disruption, global weather patterns, and economic opportunities. So these are the impact which will create due to the Arctic ice melting. So coral reef destructions. So there will be a very declining or the losses of coral reef mainly because of the impact of global warming, because of increasing in the ocean temperature and acidification creates the widespread of losses, right? So what are the key impacts? Coral bleaching will be there, biodiversity losses will be there, and finally economical consequences will be there, right? So a general case study which is observed in the European conditions, yeah, exclusive the heat waves are becoming much more rapid and frequently it is happening and affecting the human health, in turn affecting the infrastructure and economical conditions. Thus the human health is affecting and it's affecting the infrastructure, right? The buildings, bridges, and many places. And finally, the economical condition is getting disrupting. So mainly the key impacts are the health risk is occurring, the heat stroke, dehydration. Exclusively the dehydration is facing nowadays in India also. Lot of water we are consuming, but due to the temperature differences in a day by day, it creates the dehydration effect. Wildfire, as I already pointed in the last slide, destroying the homes and forests. So everywhere the economic losses reduce the worker productivity, energy demand for cooling, right? In many places we are using the ACs, air conditioners to get rid of from the heat, right? So it was given the case study over 200 thing, 200 think how much people they have been died and how much casualties was occurred. This was a very pathetic scenario. This is not we are telling this is a natural disaster, but truly speaking, this is not a natural. Due to man-made, the natural disasters are happening. This is water scarcity in South Africa. Actually, the NASA they have pointed earlier in 2019 or 17. In 2025, the India will face the water scarcity. So like that we are facing nowadays, right? So immediately within 5 to 10 years, we will face like in Europe as well as in Africa, uh, because of the various changes in temperature. You can see it in the photo, how the people they are standing for getting the water, and you can see how there is no proper agricultural area. Almost all the places are dried, right? So creates the impacts of drought. Most of the cases in South Africa's very pathetic situation in getting the food for in all the times, right? Food insecurities occurring, right? Health challenges, right? So in Europe, in Africa and all, you can't see the people very difficult. They're more affected by the health in terms of age, in terms of weight, right? Proper food is not getting. And finally, what it is happening, the people are migrating from one place to other place. So mitigation strategies, how to avoid this, how to control this, reducing greenhouse gas emissions is very important in the graph I have pointed very clearly or how much amount of emissions is happening, which is given in the orange color. Due to production, how much amount of occurring is the, and vehicle production, how much are occurring is the, these are the greenhouse emissions, and it is well clearly compared with the electrical vehicle, right? So that in the modern days, the people are slightly migrating from the petrol or diesel vehicles to the that is battery vehicles. Obviously, the initial investment is more, and also we need to, it will take long time to switch over or to adapt to that particular system, right? So greenhouse gases emission critical to mitigating global warming and limiting temperature rise to 1.5 degrees centigrade above pre-industrial levels, right? So if you want to submit a research proposal to the government of India, like DST or any other agency, right? So people are much focusing on reduction of greenhouse gases, that exclusively the carbon dioxide emission. So many places in startup mania, as well as the many SDG goals, there is 17 SDG goals. So in that, one of the SDG goals is making the infrastructure to be very green city, right? So you please concentrate much more on emission of stopping the emission of greenhouse gases, or utilizing or capturing the CO2, how to trap it, that is called trapping, how to, or trapping or sequestering, how to sequester the CO2. So we are using the aggregate, recycled aggregate for where we are passing the CO2, and the CO2 what we are using is used for the construction of building blocks, right? So what are the key strategies? Energy efficiency, industrial emission control. You need to make the industrial emission control. You can keep the meshes, or you can keep the filters at the top of the chimney or intermediately to the chimney. You can control the emission such that it will not go beyond the limit. Transportation changes, alternatives, we can use it, right? And 4 stations, right? We can plant more trees to absorb the carbon dioxides, so that in the NHS and all, intermediately they have planted more trees in order to absorb the CO2 from the vehicles. So there should be a proper enforcement needed to be there. Government is frequently insisting, both state government as a central government, they keep on insisting to control the emission. You should not emit much beyond like that. So enforcement should be there. It should come into the agenda. So transition to renewable energy, right? So renewable energy means how we can, like solar power, generating the energy inside itself. So people nowadays, we are using solar panel in the roofing, consuming energy, it is converting into alternate sources. We are using the same for burning the lights and for any other activities also. So somewhat we should not use the artificial energy. Take for example, piezoelectric transducer. Nowadays in the foreigns, they are embedding in the pavement itself, where the piezoelectric transducer will convert the mechanical energy into electrical energy, right? In the pathways they are using, in the villas or apartments in the ground floor, where there is a more production of energy they are using, and they are storing it in the one form they are using for the burning the lamps or some other things, right? So in the policies, national state policies, and many other things, government has came with many advantages, and asking the public to use the renewable energy adoptions rather than using the artificial energies. One other example is the generation of electricity from the dam, right? So where we are frequently using that, right? So nowadays we are in our my project, we got 5 lakhs project from the AICTE, where our ultimate objective is to, without window, how we can supply the lighting inside the building. For that, we are trying out with acrylic rods or polymethyl methacrylate tubes. We are using in a different sizes. Say, for example, 30 mm, 40 mm, 50 mm in a different places. We are positioning in the wall, in a precast wall, and we are studying the illuminance level, how we can use the daylight by reducing the artificial light. So this is our technology, and we are currently using. We are also using the construction and demolition debris. So we have created an app which is based on the machine learning, and it will identify which part of construction and demolition can be used for the building for creating the new product. So we are incorporating the same for precast wall construction, and intermediately we are placing that the PMMA acrylic tubes, and our objective is to enhance the illuminance level inside the building without using the artificial lighting. So that is the one we are using. And in addition to that, we are also concentrating much more on using the alternative material to cement, like geopolymer concrete we are using, right? We are using much quantity of fly ash. So other than that fly ash, we are also using that sugarcane bagasse ash. So in our locality, there is so much amount of sugarcane industries. We are using that. So this is a very, very exclusive, very, very important. You please note it down. And in that call to action also, I have projected here. Government is expecting a fruitful solution for this. Invest in research and scale up pilot projects for this. So if you are coming in the TRL level 3 or 4, government is ready to project. For example, IIT Madras from the past 2017, other than COVID period, they are conducting a concept called Carbon Zero Challenge. So we have participated in that first 2017 in the July, and we have got a grant of 6.69 lakhs, right? So with this, we are continuing the same, and the ultimate objective is to give a fruitful solution to the society, right? So just a minute, sir. Yes, sir. Yes, sir. Yes, sir. So I request the professors, irrespective of any department, I have given clearly the carbon emission is happening directly. They are dumping into the land. In addition, alternative to that, you can able to search for the capture. Am I audible, sir? Am I audible?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
You can go for the capturing technique. You can go for the how the transportation will, we can have the captured CO2 and how you can store it. So nowadays there is a lot of research is available. The CO2 is getting passed into the fresh concrete, and they are studying the mechanism, right? So like this, we can able to go for natural sequestration or carbon capture and storage technique, which is called CCS, and ocean sequestration. You please have it, and very, very important for getting the proposals in this carbon sequestration techniques. So shift to low carbon economies by using the battery vehicles. So like tram or something in the US and all, if we go there, there will be a tram, electrical tram will run all over the places. And there is a new technology is available nowadays called Hyperloop technology, where you can have it in the net. In addition, what the people they are using now, Hyperloop technology is a very advanced technology where you can migrate from one place to other place in a very shortest span. Minimum speed is around 800 km/h, like flight speed. It's like a capsule where it's like a bullet train will be there inside the capsule. You can enter into the bullet train. You can shift from one place to other place in a very faster rate. I'm telling minimum 800 km/h. Nowadays, IIT Madras and America, they are tie up and they're designing for Hyperloop technology in addition to the other countries also, right? So going to like flying taxi in Arabia and Gulf and all, there is a flying taxi available. So how you are reducing the mode of transport in the ground such that you can able to reduce the global warming. The international cooperation treaty has been signed, Paris Agreement has been signed in order to strengthen their commitments and to enhance the global collaborations, right? So carbon pricing and policy framework in order to expand and channelize the carbon pricing mechanisms in a globally, exclusively for the paneling, that is solar paneling installations, and government they are giving in a very minimizing rate for the applications installations of the solar panel in different places, right? So government is supporting in all the way in order to avoid the global warming effect and in order to come to the low carbon emission technologies. The infrastructure resilience, you can see how the government sector they are investing in the resilient infrastructure exclusively in the flood defenses. Take for example Rameshwaram, right? They have made the new bridges, right, to migrate from one place to other place, the shipping as well as for the train migrations. So we need to consider much more the flood defense infrastructure resilience exclusively with respect to the rising of sea level as well as with respect to the extreme environmental conditions. So if you are designing the geopolymer concrete, our main focus is on environmental condition, right? So you should not the molarity with respect to the environmental condition. The molarity will change with respect to the environmental condition. So what are the key mechanisms we need to focus in mind is the reinforcement. What type of building we are using, whether we are using for reinforced buildings or we are using for the green infrastructure or we are using for the repair and rehabilitation, etc. Right? So there is a correlation between the climate and smart agriculture. So earlier, there is a pond which where we will store the water for the agriculture. After that, we are using the drip irrigation. And nowadays, in the modern scenario, we are using the sensors to observe the humidity level in the sand or the soil. And based on that, the spraying of water will happen. In final day, in current scenario, drones are using to spray the water over the agricultural land and it will continuously spray all over the area to improve the agricultural fertility, right? In order to have the sustainable irrigation or in order to have the soil conservation, etc. Right? So early warning systems, which I have which I have told you in the previous session, AI tools, early warning system are giving indication to the agricultural people based on the weather, right? So which will save the life and reduce the economical costs mainly for the adverse environmental conditions, which will call community alerts using the SMS, radio, or any other tool for giving the indications, preparedness plans, and weather monitoring. So these are the very important key mechanism using for the disaster preparedness. So nowadays the people they are using IoT. Now we are working with the project with the computer science department and IT, right? So how to give alert to the agricultural field in IoT based method such that we need to get prior information saying that your agricultural land is getting drying. There is a need of water for increasing humidity like that. So in order to improve the response and recovery, there is a need for early warning systems, right? So community based like NGOs, in order to participate or community outreach should be there. government are giving more policies to generate NGOs, international bodies by giving funding, right? So in participating in the appropriate knowledge sharing activities, right? So urban people should come to the rural area. They need to teach the rural people what are the crises it is happening and how we can improve the fertility in order to avoid from the global warming. Proper education training should be there, right? Urban planning for climate resilience, you can see it in, as I told already, many places in the high-rise buildings, they are using the green cultivation in their, that is called in-house farming. So policymakers must provide the prioritize in order to design the building and to protect from the urban populations, right? So innovations in water management, these are also very important project proposal, like what I have told for carbon sequestration. So nowadays the governments and industries must adopt the cutting edge technologies in order to save the water for the future generation, right? Conservation and management is very, very important. So if we are conserving the water, it should be properly in a particular form. It should not get disturbed, right? The water condition should not get disturbed, right? So how we can make this recycling and how we can use the smart technology like artificial intelligence or machine learning or deep learning, or how we can use the sensors to manage the thing and to detect the leakages. Nowadays, I think you people will know that there is 72 sensors that is available for the infrastructure where you can directly embed it into the mobile. If you want to control the inlet water to the tank, you can able to control. In remote distance, you can operate. Everywhere you are having, you can operate from the remote distance. If the water gets filled, you can control the motor in the cell phone itself. So such amount of artificial technology tool is available, right? Everywhere, wherever you are, you can use this technology to make the water storage, like what the technology is available in the water doctor, right? So government initiatives in order to make for green technology deal in order to achieve net zero emissions. It's very difficult to achieve net zero emissions, but then government is planning to make it happen in 2050, right? So for that, India's national solar emission, which is promoting larger scale for the solar power production in the top, Honorable Prime Minister, they are giving a project investment of over 75,000 crores, right? So in order to get the global free emission to use the lighting in a proper way, right? So this is as per corporate responsibility in climate action, right? So Microsoft, they have developed the policy to be a carbon negative role by 2030, right? And Tesla also, as I already pointed in the first slide, they are coming with the battery technology, battery car technology. Obviously, the initial investment will be more. And second thing, the road conditions, we need to check it out, because that condition will not say for all the road conditions, mainly the battery storage. If the undulations is there, obviously the battery storage, battery usage will be more, right? So we need to see that, and day by day, by 2050, hope every country will move to the carbon free emissions and carbon neutrality goals. So the public awareness and behavioral changes, you can see it in the example. It is well clearly given, the Fridays for Future, right? So our more campaigns are conducting in order to create awareness to the public, to change the behavioral aspects as a community initiative, right? So technological innovations, as I pointed in the Switzerland, you can able to see the Climeworks carbon capture plants is installed in Switzerland. right? And we are also doing the modified aggregates for using it in the concrete in order to have the recycled aggregate concrete inbuilt with the carbon capturing technology. Artificial intelligence tool for climate monitoring, right? As I already pointed in the last point, drones and satellites they are using in order to prevent the earth to affect from the hazardous things. So call to action, World Environmental Day is planning everywhere. And also in Congo, we are keeping lot of activities and we are assigning the activities to the students, how we can protect the ecosystems by conducting more campaigns, more initiatives, more thing to the public. And ultimately, we need to know about 3 R's: reduce waste, reuse materials, and recycle. In China and all, they are doing China, Taiwan, they are doing much more activities, the recycling technology, right? So finally, I am ending with this quote: be the change you wish to see in the world. Thank you so much. Am I audible? Am I audible?
Sir, you are audible, sir.
Okay, sir.
Yes, sir.
Okay, thank you. So, if you are having any clarifications, you feel free to ask me. I think some of 3 to 4 slides is very, very essential for the project proposal submission. So hope the faculties, those who completed the research or the faculties, those who are pursuing the research, you can use it for your academic career as well as for your research aspects. Government is supporting much more for these carbon sequestration, water conservation technology, agricultural monitoring, right? There is a platform called Vishwakarma, right? Vishwakarma. So in that award, Vishwakarma award call for, you can able to see what are the key aspects they are asking. They are asking more about agricultural aspects. So if you are doing the prototype and if you are coming in the tier level 3 or 4, you can able to easily submit to the particular forum and you can able to get the fund over there, right? So with this, thank you so much. If you are having any queries, I'm ready to answer for that. So am I audible?
Yes, we are audible, sir.
Okay. So if you are not having, if you are having any queries, you can ask me, or if you are not having any queries, once again, I thank you so much for the patience hearing and wish you all the best for your academic career. Once again, I thank the organizing committee, Dr. R. Shanmugam sir and his team for, yeah, I think one person has raised the hand. I think Vijay Lakshmi ma'am or something like that. I think they have raised the hand. If you are having any queries,
Sir, good evening, sir.
yes, ma'am. Yes, ma'am.
Sir, I am textile department.
Yes, ma'am.
Sir, I have one doubt.
Yes, ma'am.
You told about sugar can backseal, right?
Bagasash, yes, ma'am.
Yes, sir. So, if the product you are putting for this purpose, for only civil purpose, or you can make a fabric itself also we are used.
You
Because
can
I'm a
also try it.
textile, that I'm asking.
You can also try it for the fabric also, ma'am. But before that, we are trying its chemical and physical properties with respect to the fineness of the material. So sugarcane bagasse we are extracting from the molasses, and if
Yes.
it, after getting drying, we are incinerating the same, and now we are studying the paper from IIT Madras. So more papers they are relating to incineration beyond 700 degree.
Oh, okay.
Just a minute, ma'am. Just a minute, ma'am.
Hmm.
So incineration process is the main challenging, ma'am. So incineration process, if you are doing beyond the higher temperatures, what it creates is creating the emission of the CO2. Again, we are telling that when we are producing the CO2, the emission of CO2 is happening. For that, in order to reduce that, we are using the sugarcane bagasse. But when we are incinerating the sugarcane bagasse for increasing the fineness of the particle, again the CO2 is getting liberating. So it is a challenging task where in current study we are in the property checking. After that, we will tell you whether it is good to, how much amount it is good to be safe for the next production. Hope I have given some comments to your question.
Okay, sir.
Okay, ma'am.
Thank
Thank
you.
you so much. Thank you, ma'am. Thank you so much. So, is there any questions or? So, thank you so much. I think it's time for the next speaker to come. If there is no any queries, thank you once again for giving me the opportunity. I thank entire crew for providing for arranging this wonderful platform exclusively the disaster management and resilient infrastructure, which is the need of the day. And I thank All India Council for for sponsoring this program. And I welcome Professor Anthony sir for this program. So thank you so much. Have a good day. Thank you.
So let me conclude, sir.
Yes, ma'am. Yes, ma'am. Please proceed.
In today's session, he dealt effects of global warming, and he also covered case studies of global warming impact. Arctic ice melting, core reef destruction, heat waves in Europe, water scarcity in Africa. He also dealt carbon pricing and policies frameworks, urban planning for climate resilience, innovations in water management. We thank you for this wonderful session, sir.
Thank you, ma'am. Thank you so much. Shall I leave?
Yes, sir.
Okay, ma'am. Thank you. Thank you. I think the next speaker, Professor Anthony sir, has joined.
Okay, sir.
Welcome you, sir, Anthony. Sir.
Start my intro, sir.
Thank you.
Thank you. Thank you, sir.
Participants, kindly fill the feedback form for this session. Followed by second session will be handled by Dr. Anthony sir. ATAL Academy prefers 2 foreign experts to deliver the lecture. We contacted Dr. Anthony sir through Dr. G.S. Ram Pradeep sir, Kongu Engineering College, Erode, and Dr. U. Johnson Algram sir from Malaysia. He kindly accepted our invitations to deliver the lecture for our faculties from diploma institutions, engineering colleges, and universities. Now, I'm happy to introduce Dr. Anthony sir from Indonesia, presently working as a professor at Petra Kristen University, Indonesia. His area of expertise is concrete technology, construction materials, and building damages and repair methods. He holds his bachelor degree from Petra Kristen University in the year of 1998 and did his master degree from Asian Institute of Technology, Thailand in the year of 2001 and did his doctorate from Hokkaido University, Japan in the year of 2004. He has 20 years of teaching experience and 10 years of Indian industrial experience. He has following professional certifications, namely Lakshya Certification, Research Assessor Certification, FKK Public Engineering Expert Level 9, Engineering Registration Certification, Expert Appraiser Certification. He also member in Association of Indonesia's Construction Expert, Indonesian Engineering Association, American Concrete Institute. He is awarded in Outstanding Lakshya 3 in the Science and Technology categories, Silver Awards, Best Paper in Civil Engineering, Civil Medals, silver medals for the innovation of artificial rocks for losing mud. He has undertaken community services like assessment, post-fire building, construction evaluation, evaluation of cracks in rooftop concrete slabs, structural reviews, short courses, evaluation of steel failure, technical training, workshops, evaluation of the cause of damage, evaluation of post-fire condition of building structures. He published more than 40 journals and also published 9 books connected with fly ash, architecture and civil engineering, sustainable structures, geopolymers, civil engineer innovation, development in structural engineering and construction, conservation of buildings, concrete technology. He has present experience in formulating public policies like specification for light bricks, procedure for calculating concrete structure for buildings. He has 3 national patents and 1 international patents. We welcome you for the session, sir.
Thank you. Thank you for the kind introduction. Good evening, everyone. My session today is about the building resilient infrastructure for disaster-prone region in Central Indonesia. I hope what I share can be beneficial to all of us. You can hear my voice and see the presentation.
Yes, sir.
Okay.
Presentation is visible, sir.
Okay. And also thank you for the kind introduction. My university is in the Surabaya. This is the map of Indonesia. As you can see, my city is quite center, Surabaya. That is the second city in Indonesia. So I'm from Petra Christian University. It's also a university in Surabaya. So let me outlines what is my presentation for the day. I will provide an introduction and context to Indonesia disaster-prone environment, and then we will review cases study from major disasters that happened in the last 20 years, and then also I want to show 2 of the topic that I think is relevant. That is one is the lesson from the traditional Indonesian architecture, and also the second is for the low damage technology that we are currently working on. So, and then after that, we will continue with the concluding remarks. So, as an disaster-prone region, we can see Indonesia is here, in the ring of fire, we call it, because there is a tectonic plate in around Indonesia. So this is a very active region. So the earthquake, volcanic eruption, tsunami, we can encounter. So the diverse terrain from active volcano to coastal area increase the risk, including floods and landslides. And also we can see the rapid urbanization is also complicated the disaster resilience effort. So in this condition, the Indonesian have many earthquake each year. We can see that there is a big and small earthquake here is also mainly occurs in the southern area of Indonesia. This is, we have a country with the islands. So there's 5 big islands: Sumatra, Java, Kalimantan, Sulawesi, and also Papua. This is our main island. And then there is a movement of the tectonic plate as shown here. We get the movement about 5 to 6 centimeter in this area, 7 centimeter. So the movement is causing the collision of the tectonic plate, and then there's a significant earthquake in this area. And also this is the Sulawesi area, and then so most of Indonesia is disaster prone, and we can see here the less occurrence of disaster is in Kalimantan. This is in the center, so that is why the in Singapore, Malaysia, and Kalimantan part of Indonesia is have a quite low risk of earthquake occurrence. So, and then this is the distribution of the population in Indonesia. So you can see here that the main population live in Java. This is the Java part. And then when disaster occur here, there should be very troublesome because the damage at the casualty to the people will be high here. So this is a very dense populated, and then this is the Sumatra area is less populated, and then other part is also less populated. So we can hear this is the blue line. This is the Aceh. I think everybody here know the disaster of earthquake in 2004 of Aceh earthquake occurs here. So when the tectonic plate hitting the this region, and then there's a release of energy, and there is a very big earthquake occur here, and then cause a lot of damage. But the population is less. That's why the casualty is not as high. And I will also show other earthquake, but later on in this slide. But you can see that the risk of the earthquake is high in the red marked area, and then also the Indonesian government also make the flooding prone area. So we can see the disaster is quite distributed in the Indonesian region. Although this Kalimantan, this island is less no earthquake, almost no earthquake, but there's still possible of flooding in some area. And in Java, there's a quite high potential of flooding. Also, that's why when they make the disaster in Indonesia disaster risk area, we can show mainly the region is in the red area, and then this is causing further troubles of the controlling of mitigation of the disaster in Indonesia. So I want to show the key event, like there's a very big earthquake that have a big casualty. There's this three earthquake that I show here. It's a 2004 Indian Ocean tsunami. This is a big earthquake starting from Aceh. And then the second one is a 2006 Jogja earthquake. Jogja is located here in the center region of Java. This is the blue line. That is why this is a very significant due to the closeness to the populated area. That is why when there is a earthquake hit there, the damage is significant to the people. And then the last one is a Palu earthquake. Palu earthquake is happened in 2018. Palu is a city in Sulawesi. So this is the area. I think if you can later on, I will also show the area is in here. The population is very less, but still there is a significant damage. Also, I mean, this is just the few earthquake. Of course, in every years there is a smaller earthquake occurrence in around Indonesia. So we still get the earthquake. I mean, many earthquake each year. But this is the very big event that I'm going to show. Okay, let me start with the earthquake, Aceh earthquake. I've shown you the location is here. I think this is like the biggest earthquake that previously not recorded, because when the earthquake occurred here, I think it's about nine point something. Yeah, it's been 20 years. Yeah, last year December we celebrate the 20 years of the disaster, and still affected. So there's many news here also, like showing what happened to the region after 20 years of disaster. So this is about 9.3 earthquake, and then a massive tsunami. This is the big news for everyone, because when the tsunami hit, the wave went up to India also, I think. And then in Aceh alone, about 167 people lost their life, and more than 500,000 were displaced, because all of them, all of the city is destroyed. So yeah, this is the disaster. And then this is like one big disaster. And then we can see that the building, even though it survived earthquake, the majority of the building was wiped away by tsunamis. So this is one disaster that have a two energy that need to be resisted by the building. So like when you can see many in the, this is just part of the picture. Like if you want to see the details, you can search. I think the data is everywhere. But what I want to highlight is like this kind of structures can withstand both of the earthquake. Like this is a mosque. So mosque is like full of openings. When there's a earthquake, the element is not quite heavy also. It can resist the earthquake. And then when the tsunami hit, there's many openings. Also the building can survive due to the water can flow through the building. So this is a two kind of response of the earthquake, and also when the hit with tsunami. And while all others building were destroyed, and even the boats from the coastal area hit the city, and then causing a very disastrous condition in the city. And then the earthquake of 2006, I think when the earthquake in that region, in the southern area, is like continuing. So we have an Aceh earthquake, and then Nias earthquake. Nias is a southern part of Sumatra, and then Padang is also in the Sumatran island. And then in 2006 we get the Yogyakarta earthquake. So as I shown here, the earthquake is like 2004 occur here, 2005 in Nias, and then 2005 also occur also in Padang. And then when in here there is no earthquake, I think the energy got released. And then 2006 there is an earthquake in this area. This is a Yogyakarta earthquake. So in the condition in Yogyakarta, although the magnitude is quite low, 6.3, that is not very high, but there is also a significant damage, maybe less death due to the occurrence of earthquake is lower, the magnitude is lower, and then there's no tsunami. And also I think the earthquake is happening still manageable, but the destruction of the homes is significant. So we get the big vertical movement of the earthquake. So many places also get destroyed. So during that earthquake, because I'm from Surabaya, we can also visit the city and then investigate the aftermath. And then this is the 2018, the quite latest. So I shown here, this is the location of earthquake in Sulawesi Island. So this is the 7.4 magnitude earthquake that's struck Palu and Donggala. This is 2018. And also there's some tsunami that hit about 11 meters. So the one thing that is very devastating is the liquefaction phenomena. So when we can see this is the region, the satellite image of the area, and then when the earthquake hits, everything is liquefied. Yeah, liquefied. The land, the soil was liquefied, and then we can show there's a very big movement of land. So all of the area in the city is get moved around, and then all the house is not only uh, destroyed by the earthquake, but also due to the landslide and liquefaction and then the movement of soil. So this is also causing a very big damage. Even, and then the normal building, however, we can design it, it will not survive due to the movement of the soil under the building. So this is a very different response process of the earthquake. So the fatality is yeah, considering not very high, but due to the lower populated area in that part. So this is the condition. And then, yeah, we can see, I think the data is, we can show that many earthquakes happen already in Indonesia. So like when we survey the damaged area, like we shown that there is a significant lack of controls in the building codes and also the construction. So like this is mainly the picture that I got in the Yogyakarta. This is even in the center of Java, where most populated area, and there is many educational institute there. We can get the very lack of design. So we can see here the details of the building. This is building quite new. I think it's about 2007, got destroyed during the earthquake. And we can see here that the lack of stirrups. So this is mainly the design, and then the details of the building was not on par with the current code. So the design code is already implemented, but the many buildings was not up to following the code. And then we can see here, this is also a damaged building, and even some part of the area, we can see there is this is like a wall for the building, and it's not lack of the structures element. So there's no column and no stirrup, and no flexural rebar in the column. And this is also the happening. So for the small building, there's a damage. I think if you want to look for the damage, we can see here. But like what I want to show is, even though there's a big building in Java, we like to use a very heavy roof. So normally we use roof from clay roof, and then we put it in the building. So this is all the material heavy part get broken during the earthquake, and this is like a less width of the roof, so it can survive, but still get destroyed. And this is another building. This is a hotel, I think. So there's a process of construction is in stages. So also that is also a big concern, because when people are building their home, or people building some kind of a commercial building, sometimes when the capacity is not enough, they increase the level and add some new section in the building, and then the connection of the building is not properly controlled. So like what we shown here, I think this is still common. So I talked with my colleagues already. So this is like he said that the problem is like still the same, even though in 90s, in 2000s, and even up to now, many problem is due to the connection detailings. So when there's a building, we have to design, we can design it to be earthquake resistant. The design is good, but when the construction periods, there's a lack of control in the detailing. I think the most significant details we shown here is just like the stirrup should be bent 135 degree. So 135 degree, so that when the concrete is cast, the stirrup is keep inside. And then most of the construction, they just use 90 degrees. So when there's a big movement of the column, the stirrup can open easily. So this is a very common process of construction. So even though there's many details already shown, but sometimes lack of control and lack of awareness of the details causing the damage. And then the second thing is the staggered connection I mentioned previously. So staggered construction. Staggered construction, I think it's easier to see that when the family is still small, like one father, mother, and then children is still small, we just need 2 rooms. But when the children is growing up, they need their room, and then the house is increased. And then normally they just remove the roof or just add a new part, like some level in the garage area. And then the connection is just mainly just for the just like a simple connection. It's not anchored into the previous area. And we see this kind of construction in Yogyakarta, because the people are building homes mainly in the staggered construction process, and also some hotels, also some commercial area. When the capacity is already reached maximum, they just increase 2 levels. So this is also a big problem to the construction. And then the lack of awareness. So yeah, for homeowners, and maybe also due to the economical reason, I think, because when we can build, normally we just build for the gravity load, right? And then in disaster-prone area, people, even the owner, are not aware. And also, like, this is the design oversight. We also encounter many design oversight. So there is a very big mass of the building, and then lack of anchorage also cause damage in the building. So design oversight is also shown. This is like one example of a building still under construction. Even the outer area have a what do you call, a ring bulk, just a closing rebar up on top of the wall, but some part is not anchored properly. So when there's earthquake, the wall is not properly anchored. Okay, so that is the common problem that we encounter. And then yeah, earthquake still happening, and we still continuing. So like there is I want to show here an initiative from the government to make like affordable housing. So they make a design, like they call it RISHA. RISHA is an acronym from Healthy, Simple, Instant House, of course in Indonesian. So the element is quite simple. So all the part is can be knocked down, and then the connection is ensured by the ball connection. So easy to build, affordable, earthquake resistant. And then I think the housing is like this, and this is just like a blocks. So you just connect the block, and it's not anchored on the ground. So you just lay down. But of course, we need to have a proper level surface. I think this is also a good good design. But of course, there is a development, and we can make a bigger one. So this is just segmental part. However, the application of this kind of building is not much. Mainly, it's government subsidized and mainly implemented during the disaster. So after Aceh and after Palu, they also send this part to the region and then use it for the housing for the people. And due to the lack of the construction guide, I think many academicians also like help the people to make a guide. So construction guidance, there's many. This is one Teddy Bone, I think is also famous in Indonesia. He proposed a very simple construction method, even the wall using the mesh and then the plaster, it's like a mesh wall. So the design is very good, but of course, like design and implementation is a bit different case, because when we add cost, some people just don't want to spend that cost for the increasing the details. So there's many guidance, but however, the implementation is not enforced. So yeah, this is still one thing that happened. So like for the summary of the condition, the disaster risk and awareness is a major challenge, I think, because when the complacency and then widespread code valuation and then limited public understanding is leads to many structures deficiency. So this is also a problem that we are facing. And yeah, this is still going on. And then that is the condition of the disaster in Indonesia. So I want to continue to the next topic. So I think this is also very interesting to show that like the earthquake is like cyclic. So I think people in Aceh, people in Nias, they already know that there is a earthquake happening every like 20 years, 30 years. There's a significant earthquake will happen. That's why the people is already building housing that can withstand the disaster that happening. So this is the like an examples of the traditional housing in Indonesia. So like this is Omohada. This is in Nias. This kind of structures stand on the stone. So these two type of structure we'll discuss this further. And then this is like Rumah Minang, Rumah Gadang. This is in Sumatra. Yeah, most in Sumatra. This is in Kupang, all part of Indonesia. We can see that this kind of structures we can see for the traditional people. So in Indonesia, there is a of course seismic occurrence. I think people already know, and then the architecture is also the adapting with the challenge of the region. So we can see here that the traditional building often combine natural material, bamboo and wood that are flexible and earthquake resistant. The construction technique also used to design to absorb earthquake energy and reduce impact. So I think the main focus, like currently we already know what what is the good design for the earthquake resistant building. And then but in previously they just based on the experience and then the experience of the surviving building. So when they see, oh, this kind of building can survive, so their neighbor, when they are rebuilding their building, of course making the use the same kind of design. And then the earthquake prone region also use a lightweight structure. That's why the lightweight material also reduce the damage to the building, because when there's a very big earthquake, the building have a less force in their structural member. And also the main part is like we realize or unrealized the building is stand on the some kind of support. So it's like the base isolation model. So like this is the traditional building. Do two examples that I've shown here. This is also research from my colleague. So Omohada in Nias. Nias is in the southern part, in the northern part of Sumatra, and then the Sumbawa. This is in Kupang, eastern part of Java. I think this is the traditional housing. So yeah, the footing is like this one. They all designed the footing of the house using a wood, and then it was placed on the stone, so the wood will not rot when there's a connection to the ground. But this kind of the connection is can be considered as column friction for energy dissipation. This is the condition of the building. So like for the Omohada, there's many diagonal, so the stiffness of the building is quite high. So we can see here that mainly due to the experience, when there's earthquake, the building will behave like a solid blocks on the moving platform. So I think that is the design, and this is a traditional design, and even the modern buildings already understand this kind of design. So, and then the bottom, this is like yeah, similar to base isolation model, but for modeling we use column friction. So we can get technical insight from traditional design. When the modeling traditional structures is quite difficult. So due to the joints is normally assumed as fixed. However, when the real connection of wood is normally using struts, so there's some kind of movement, not really fixed. And then the model of the connection of the friction is also can be varied. So the testing normally we cannot done on our design, but this is a traditional building. They're already tested one by one. So the full scale model already tested, and then the design that are surviving is already proven by the standing building. So previously damaged building already been demolished and also already been modeled to show that the latest design should be the best one. And then yeah, effective design, but this is the design need to be like model for the modern building, of course. So this is the result. This is the paper of my colleague. I think they model the construction of this traditional building. This traditional building I visited, and then it's still standing up after after many earthquake, of course. We can see here that the design is like very stable, with the many stiffener. And then like three type of advantage of this kind of building is like when there are earthquake, of course there's some movement. When there's a flooding, the flood will pass through the bottom area of the house. And then when there's like tsunami, also the same one, so there's open. But mostly this kind of traditional building, because due to the previous experience, they still build the building with higher ground, so farther than the seashore. So this is the model of the building, and then they can model like when what is the distribution of force in the building. Of course, it's quite low due to the many of the movement, many of the energy was released by the movement of the building. So this kind of model also done by my colleague when there's a quite stiff building above the friction base. So when the result is shown like this one, when the coefficient of friction about 0.4, there's a like when there's earthquake, there's a movement. So from 0, there is about 25 millimeter of movement for this building. This is like a simulated condition. So when the building move, actually what happened is like the energy of the earthquake was not transferred, was not absorbed by the member, but then they are just absorbed by the movement of the building. So this reduce the energy on the structural member itself, just change it into the movement. So this is and then the friction coefficient was varied also. Like when the friction was too low, of course there's no like dissipation of energy. But when it's too high, the friction was too high, is similar to when the building was just locked into the ground, and then all the energy was absorbed by the structural element. So there's a balance for that one. So like we already know the modern building use a base isolation. So the base isolation system causing the deformation in the building was less, and then they just move more energy was just changed into the movement energy. So there's an afterthought from my colleagues that like the current building, yeah, we still need to think whether we should anchor the ring block, the what do you call, the structure for the floor to the foundation, or we can just put the building. Of course, we need to make it slightly wider. So, and then also there's a ground and everything. Yeah. So this is the process that still need to be considered. So challenges in modern adaptation also was think, and then I think he also made a paper after this to model a more common building with the column friction modeling. And then yeah, of course, when there's a reduction, there's a movement of the base area, there's a reduction of deformation in the building, of course, and then the damage on the building should be reduced. But the practical application need to be considered, like when we are thinking on how the cultural condition of the people, and then technical. And when what happened is like when the building was used, of course there's some maintenance issue that need to be addressed, because when we are making we are allowing movement of the building, then what happened is the maintenance, we should not like make the design is cannot happen due to the lack of maintenance. That's what I'm saying. And also in Indonesia, mostly of the building was non-engineered building. So like you've seen the guidance that I shown you. Most of the house is just a common housing with the column and then the wall and then the roof, one story level, 2-story level. So it was not designed to resist earthquake. So majority of our private housing was built without engineering design. So without engineering design should be okay if the details was done correctly, but the insurance of the detail is also not enforced. So, and then for the retrofit programs, yeah, still a big program. And then regulation, we have a earthquake standard and we renew it every 10 years. So I think the standard part is already good, but the implementation is still need to be improved. So I think that's conclude my talk for the third segment. So yeah, the fourth topic that I want to talk is about the low damage design technology for earthquake resistant. So this is also one of the concern, like after we make a building and earthquake happen and then there's a damage on the building and then there's aftershocks. So most of the fatality occurs after the main earthquake shock, and then after that there is a aftershock, and then the building was not safe. So and then when people are having activity in the building with the aftershock, it's also very dangerous. So when I was visiting some after disaster area, so there's a big earthquake in Padang in I think 2005, 2006 something, and then the building was damaged, and then after 3 or 4 months, there's another big earthquake happening also. Like the previously survived building was get destroyed during the second earthquake. So this is also an important consideration, because when we are designing the building, okay, one earthquake, the building survived, but what about the next earthquake? And the next earthquake could happen like after that, like maybe 1 day after or 2 day after, or even like 3 months or 6 months after the initial earthquake. So that is also a big consideration. So the current philosophy should also think about the low damage design technology for earthquake resistance. So I want to show, this is these are pictures of crash church in New Zealand. This is a photo, like when the one town is very peaceful. You can see after the earthquake, there's a big earthquake in February 2011. All the city got destroyed. So the city got destroyed. And then this is a presentation from Professor Pampanin, who is keen on the precast structures. So the damage on the building, yeah, is immediately shown. So when the big damage on the building, okay, the building was the building was not collapsed. That is the main design. When people designing buildings to resist a big earthquake, they design it so the building will not collapse, so the people still can survive. And then, but after that, when the people already, when the earthquake already stopped, and then people need to restart their life, all the big and damaged building need to be demolished. and then that's also a significant cost. And also, like the low damage is need to be repaired. So the damaged area need to be repaired. And then, like I previously said, what is the performance for the next earthquake? Is it will be the same, or it will be better, or even will be less? So that is a big question. For the topic that shown here from Professor Pampanin, he is showing that there's a one building from using precast concrete, and although there's no damage was shown, but the lack of confidence on that building causing the building to be demolished, even though we've seen that the design was good, and then the performance after earthquake was still good, but due to the lack of confidence on the soundness of the building, so the building also got destroyed. So because the building was not designed to be able to be a low damage, so I think that is also one consideration. So we already know that when designing building, of course, when there is a low earthquake, the building should be fully operational. So this is a normal low low magnitude earthquake. And then when there's a higher, still the essential building need to be still fully operational. When there's a rare or very big earthquake, still the life safety should be the goal. And then very rare collapse, near collapse should be the goal. So yeah, when is the repairable and when is irreparable, that is the consideration. So the need of low damage design, I'm showing that the traditional design, seismic design, focus on preventing structural collapse during earthquake, because what is the consideration of the designer is they're just saying that we design it so when big earthquake happen, it will not collapse, and then after that we need to rebuild. So when they are designing for that kind of building, so when disaster happen, the cost for rebuilding is very high. So the new paradigm should aim on low damage design to minimize damage to the structure during earthquake. So I think this idea is very simple. Like when you are having many component like connected by pre-stressed material, so after movement, it still can continue in going back to the original state. So the damage control technology previously developed already, like the three key strategies, like base isolation, radiation here. Base isolation is separating the structure from the ground. Of course, the technology now is very advanced. We just use the rubber bearing, and then the dissipative braces. So when there's a movement of earthquake, there's many brace in the building, and then to absorb the movement, and then to reduce the stress on the structural element. And post-tension rocking mechanism is kind of the part of the structural element was connected using the post-tension cable, and then after the earthquake, they will move back to its original position, just like a toy. So yeah, this is also like example of the big building using base isolation in Indonesia. Like last month, we have a seminar on the earthquake condition in Indonesia also. So this is a big building using, this is a locally sourced. So previously they don't have this kind of rubber bearing, and then in Indonesia they can produce it now. Previously we need to import from Europe. So this kind of rubber bearing, and then they build the hospital. Of course, this is a very important building after disaster. So this is also in Palu. And then there's a like example for housing, premium house. they can also make this kind of small house, and then they can make a big connection. So, but this is the cost is of course significantly high, because you have to have like 2 levels of the building. One is for the foundation, and we can see here there is a 5-point connection, and then the upper part of the building was built above the connection. Of course, this is similar to the traditional building that I shown previously, but of course with the modern design. And then, but this process is very expensive, of course. And this is also like a building for the school building. They make a school building with the earthquake resist with the base isolation. So the design is still common and can be applied already, but still the cost is very high. I mean, comparatively. Previously, we also considered when you have a low earthquake, low seismic force on the building, should the member should be smaller. So this is also a consideration when there's a base isolation. Normally, you would have a smaller member size due to the force is lower, but still the cost, I think, is need to be considered. So, and then this is the model for the self-centering. So there's a using unbounded post-tension tender bar in the center of the structural member. So when the I think if there's a picture here, like similar like this. So the structure can have a rocking movement. So, but there is no energy dissipation. Only after movement it will return to the center. And when we normal structure, we use a mile steel. When there's a movement, there's a damage on the mile steel. So there's a damage, so there's a yield, and then return. So this is the of course energy dissipation mode. And so what the system wants is like we have also self-centering and also energy dissipation process. So the low damage design concept is minimizing structural impact. Number one is we need to reduce the damage. So yeah, the design normally using the precast member. So the connection, we just need to ensure that the connection will be damaged, control damage, of course. So, and then the structural member was not having a big damage. Even if it's damaged, then we can just replace the part of the members. And then we need to increase the resilience and then recover quickly. I think that is the keyword. After the earthquake, we can recover. And also the occupants was protected during earthquake. So evolution of design approach, we've seen here that since 1970, the traditional design only focus on preventing joint shear failure. So we need to be connection. So connection, we are ensuring that the connection need to be survived. That is why many stir up in the construct in the joint, but still, like the stiffness will increase the damage in that part. And then after that, there's a capacity design. Capacity design just prioritize the failure should have occurred in the flexural mode. So the flexural mode, the beam can deform quite significantly, so other part will not be damaged. And then after this, low damage design need to be implemented. So like this kind of movement of the member still can be allowed during the big earthquake. So the damage is only localized, and then we can just inspect the connection part after the earthquake, and then we can just replace it when there's a damage, and then ensuring the safety of the building. So Previous research has been conducted, I think, by Professor Presley in Tau. This is 1993 already. So the model is the same. They use a center, I think center pen, or just the connection. So yeah, the damage avoidance designs is also improved. So changing to the minimal damage. Normally there's a strand, a prestressed strand in the concrete. So ensuring after the movement, they will return to the center point. So this is the model that normally being used. And then the design, the paradigm is that after the earthquake with the specific design level, the frame structure will still remain operational and it will not collapse and repairable following very rare earthquake. And then there's the energy absorption. We can use mild steel bars or other dissipators to be replaced after an earthquake. So yeah, this is the latest research, but we are still developing to implement the damage control design. So my colleagues is researching the hybrid connection and evaluating the performance. So in our lab, we have this kind of structures. This is a reaction wall, I think about 50-ton reaction wall, and then this is the connection, the column and beam connection that we are designing. Of course, we can see here there's a strand to ensure the self-centering process, and the connection is we investigate using the precast member. So the connection is using both steel angle and bolt. So this is ensuring that when there's a earthquake, only the connection will be damaged. So when under tension, it will deform, and then the opposite side will deform. So the performance is being evaluated, and after the damage, we can see what is the capacity, and then we replace the damaged area, and then we can check again what is the performance afterward. The research is still ongoing, of course, but yeah, this is some specimen that being tested. So I will go to the concluding remark and future direction. Like we already know that the importance of resilient infrastructures is mainly to protect life. So resilient infrastructure is critical to protecting life during disaster. Designing building, transportation system, of course, this is all need to be considered to minimize casualty and injuries. And also, next step is to minimize the economic impact after disaster. When we are seeing that the Indonesian region is very disaster prone, like what we are building need to be considering the economic impact after the earthquake or other disaster. The economic activity will be disrupted. So this is also an important point to make a resilient in infrastructures. Also, the post-disaster recovery, and so the one that we are showing, that the low damage model of the building would essentially expedite the disaster recovery. So, and yeah, this is the key lesson learned from disaster. I think early warning system, after the tsunami, there's a big funding to make early warning system. But like, yeah, the problem is like with the maintenance of the sensors, because sensor will degrade over time, and then the disaster will not happen like maybe once in 20 years. So like sometimes the sensor will be outdated and damaged and everything. So this is also still a big problem in Indonesia. Integrated disaster management, there is effort from the government, and then the community engagement is still. Yeah, so still we are on the process to consider this disaster. So yeah, let me see. Let me go to the last slide. The concluding remark is like building a more resilient future by learning from past disaster, adopting best practice, and implementing innovative solution. We can create more resilient futures for Indonesia. And then the key of achieving lies in the collective action, collaboration, and commitment for sustainable development. I think, that is my presentation. Thank you, everyone, for listening. Okay. Yeah, we still have time for a discussion. I think if you have a question, you can. Please, if you have a question or discussion, we can have some time for discussion. If you have question, then
Sir, actually, Indonesia is highly prone for earthquake and tsunami, sir. Do we have complete control at present, sir, for any damages or prevention of life, sir?
sorry, sir. Yes.
Sir, actually, Indonesia is highly prone for earthquake and tsunami, sir.
Yes.
Do we have complete provision for to safeguard life and property, sir, or maximum safety? Actually, frequently we are observing in newspaper so many earthquakes are occurring in Indonesia, including tsunami. Is there any actually any advanced technology for life saving, sir?
Not so much. Like the tsunami, like in the Palu tsunami, earthquake and tsunami, or in Aceh, I think there is no early warning also. So the like after the Aceh tsunami, they are building early warning system, but the problem is with the maintenance. Like we get funding to build many early warning system, like so after earthquake, and then what is the potential modeling? Yeah, many people research in that area, but still like the implementation is not quite good. So still, yeah, we are just hoping for the best. Not there's no significant mitigation thing. Only only thing that is shown here, like the risk area, and then we just make a risk area and everything. So yeah, the three topic here. I'm showing here is like the disaster prone landscape. And so the Indonesian geographical and environmental factors making resilience planning essential. I think we already know it. I think that is also the reason why we are changing the the capital city. So the current capital city is in Java. So uh, the Java island is here. This is the capital, and we are moving to the Kalimantan around here because lack of potential disaster also. But the process it will take quite some time also.
So anybody is having any doubt, you can ask or you can put in chat box.
Yes, Mr. or Miss Salva Kumar, can I ask question, please?
Do you, sir, Indonesia have any special cell to disaster management? In which place?
Sorry,
Indonesia have any special disaster management cell?
I'm sorry, I
That
You're not aware.
Indonesia is having special disaster management cell. Like that he is asking.
management, disaster management.
Cell.
Yeah.
Sorry, the last
This is a special place.
specialist.
Ah.
I mean,
government. Sir.
yeah, government. Yeah. We have like istilah. The term is like dan
In which area, sir? In
yes.
Indonesia, which area?
We have a like a national body to mitigate disaster.
Yes, sir.
Yes,
Yes, sir. I
we
know
do.
that.
Yeah.
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 Yeah, I saw that, sir. Yes, sir. Okay. National Disaster Center, Indonesia.
Yeah. Yes, sir.
Yeah. Thank you, sir. Thank you.
Yes. They're having a very big role during this disaster, because when there's a disaster, so I think many airport also have their base. So there's a multiple base in the Indonesia, like in Bali, there's one in Surabaya, there's one. Normally they are based near the airport, so they can be deployed immediately when there's a disaster.
Okay. Thank you, sir. Thank you. Thanks.
Dan bencana nasional. Yes.
Any other questions from participant side? Please.
Please, if you have question, any more question? If not, then
Shall we conclude, sir?
yes. If
Thank you very much for the wonderful session on recovery and reconstruction of a disaster. Professor covered Indonesia disaster-prone zone, landslide, and the distribution of population. He covered the details about Sumatra Island. He dealt case studies and photographs of 2004 earthquake and tsunami having a magnitude of 9.3 Richter. It also occurred at the same time in India. He discussed also about 2006 earthquake and impact of 2018 earthquake also. And he mentioned common problems in construction. He told about the crisis of disaster risk unawareness, and he narrated traditional wisdom and integrity resilience. He advised for low damage design technology for earthquake resistance. And he also covered the base isolation techniques. Thank you for your acceptance and nice delivery, sir. Once again, we thank you and thank you for the participation. Thank you.
Thank you so much for your invitation, sir. And I hope what I share is beneficial for everyone. Thank you so much.
Thank you, sir.
So,
Participants, fill up the feedback form.
Thank you for a wonderful session, sir.
okay, so I can leave now.
Yes, sir.
Okay, thank you so much.
Thank you, sir. Thank you. Participants, kindly fill the feedback form for the session.